Now I am going to first of all myself. I am Trikeshwar from the Department of Artificial Intelligence and the Data Science. Now I am going to present a slide about understanding a star search algorithm from graph construction to the real world implementation. Constructing a weighted graph with a orientation before running the A algorithm, first of all, we must define the environment for the graph structures. There are three type of graph structures. First is node and the state. In the node and the state, the node represents the discard states of discard states with the problem space. Second type is edges and weight. In edges and weight, edges connect the nodes and are assigned a weight representing the cost, time, or resource consumption of the traveling the path. Horizontal value. Each node is assigned a erroneous value, which is a intelligence estimation of the remaining cost from the node to utilize the code. The one example is a graph using the five node from the five node is A, B, C, D, E with a weighted edges. That means that node edges contain some values, the ethical value to guide the search. For example, now we are taking a graph to I'm taking a graph to explain this. The AI searching algorithm balances the cost estimation. AI is a powerful, informed searching algorithm known for its efficiency and the gravity of the finding the shortest path. The first one is informed search. Those in the informed search combine the breadth first complementation of the adjust with the speed of the greedy best first search. In second one, the core function is A star uses the evaluation function called f of n equal to g of n plus h of n to determine which node to explore next from a current node. Third one is G. What is G of n? G of n is a path cost or uh, in the graph. The exact accumulation cost from the starting node to the current node end. Fourth one, H of n. H of n is a hereditary cost. It estimates the current node to final goal. It is called the H of n. Now we are going to execute a star, the searching process one by one. A star symmetrically expands the nodes, always prioritize the path segmentation that appear most promising based on the lowest total estimation cost. That means it always lead to travel in a weighted graph in a lowest cost. First step, initialization. Start at a node A. Node A means the starting node. Initialize open a list with the A and close the empty list as an closed list as an empty. Second, node selection. Select the node from the open list that have absolute lowest f of n value. This is the current best candidate path. Third step, expandation. Generate all neighborhood successor of the selected nodes for the each successor. Calculate its GHF values. Fourth one, Fourth step is list the managements. Add new or improved successors to the opened means. That means after visiting each node, we want to put them into the open closed list. Move the explored nodes to the closed list to prevent the revisit. This the final step is goal checking. Repeat the process until the goal node is selected from the open list. The result path is granted to be optimal if the uterus is uterus is admissible. Now, already we have seen a plain graph. This is a weighted graph. For example, we are taking it. First, we are starting at A. Okay, A in state A, we have two paths. We have two paths. We can travel to the C or else B. So f of x is equal to the two parts we are adding the both the average value and the current path cost. 180 plus 180 plus 329 equal to 447. Like that, we want to add up one by one in the each state of the nodes. Now the power of the u- ureterus optimal and the effective. The performance of the A star depends almost entirely on the quality of its uterus function, H of n. That means H of n. First uterus is the admissible uterus, crucial for optimality. It must never overestimate the true cost to reach the goal. H of s is always less than or equal to actual cost. This ensures the A star find to shortest path. Second one is consistent uterus. Ensure A star operate effectively by granting the total cost f of x is non-decreasing along with any path. This avoids unnecessary re-evaluation of the nodes. Common distance based on such as a Manhattan, Euclid, or the often some admissible and significantly purity that search base can create. Now let's we see the real-time applications of the star algorithms, where they are using and how they are using. First, they are using in robotics and the autonomical industry. It is used in autonomous robot and drone for the collision avoidance and the effective path planning with the real-time constraints. Second one is GPS and route planning platforms and sectors. They are using the A-star algorithm. It forms the basis for the application like a Google Map, quick calculation, the fastest or shortest path across the wide road network by the satellites. Third one is video games. It have a non-player character like a uh, that robot characters know like human navigation to the open world and statistic games. Fourth one is logistic optimization. It applied in the chain supply management, vehicle route, etc., warehouse autonomous to minimize the transmission time. The significance of the optimization and the effectivization is that there are four main points to acknowledge about the significance of the algorithm. Implementation guarantee, optimal guarantee, balanced approach, wide separate organization. Thank you.